So in this video, we're going to talk about the placement of exterior wall studs in relation to the structure. Okay, so we're going to focus on a steel building scenario here. So there's a couple of ways this is done. There's actually three ways that it's done. So one very common way is what's called an infill situation. So I'm going to draw some sheathing right there. And here's the gypsum board right there. Okay, so this is inside, this is outside. Now, we'll assume we're doing an outside insulated building in this case. So there's our insulation. Again, that's the most common thing going right now. And the stud wall I won't even draw the studs in here right now, but I'll just do this and erase them. So there's the studs in plan view, basically. Okay, so, and of course there'd be like the air vapor moisture barrier. But again, not getting into that systems right now. Or the science, let's get into the systems of the relationship of the stud to the structure. So one very common approach you'll see out there is a steel column put right there, okay, inside the stud wall. So I'll draw some studs in there now. The studs would be framed up around the steel column like so. So this is called an infill stud, where the stud work is being infilled around the column, basically. So what you have to look for in that scenario, of course, is the size of your column, right? So what's the size of that? And what's the size of the stud that you're using? So the most common stud size that would be used in Calgary is a 152 stud in the exterior walls. So why is it 152 and not 92 mil? I'm not an engineer, but 152 is the most common, and probably it's because with a lighter gauge stud, with a lighter gauge 152 stud, you can get the adequate wind load resistance, basically. Whereas if you went to a 92 stud, maybe you got to go to a higher gauge. So 152 tends to be the stud of choice around here. So that would just mean you got to make sure that that column is not bigger than 152 by 152. Okay, or I guess it could be a rectangle, but the square HSSs are pretty common, basically. So I did a lot of buildings like this. What we did for years, actually, if it was a smaller retail building, let's say, with not real high ceilings, we would actually do the 6-inch column with the 6-inch stud. Okay, and it just barely fit, right? So the problem with this approach is getting that gypsum board past that column without it being visible, basically. So the taller you get in the building, the more out of plumb maybe that piece of steel will be. And all of a sudden, because there's zero tolerance there, it's very hard to get that gypsum board past that column sometimes. And same goes for the sheathing. So as the buildings got taller, we started saying, well, yeah, that's becoming a problem. Buildings move a little bit, and you'll see some bumps in the drywall and stuff like that. So the better approach to that situation is to make sure that that column is a little bit smaller than the stud. And the other thing to watch as well is the base plate situation at the bottom, because the base plate gets bigger, right, than the column. So you always want to make sure that's not sticking out of the wall as well. So burying the base plate lower than the floor level is generally the way to go. Anyways, if the column ends up being, let's say, very common column size is a 178 by 178, that's normal. Engineers doing their work and they figure, okay, we need a 178 by 178. Well, that's a problem then, right? So at that point, you would probably end up with, I guess, a semi-infill situation. So if we assumed it was a 178 column, it might look something like, something like this, right? Or whatever. And then, of course, you'd have to fur around that. It'd be a little bit more than that, I guess, but you'd fur around that with gypsum board, however you need, and you end up with a bump in the wall. Maybe that's okay, maybe not. It's a design choice. So, when you're doing the infill stud, I'd say the intent there would be to bury that column. And so just to show some examples of an infill stud situation, so here's a good one here. So, what you can see in this photo is the studs. So here's your studs right there. They are being fitted between the beams. So there's a beam up there, and the foundation's down here, and the studs are being fitted between them. So if we went to a column here, you can see the column right there, and the studs are being fitted around the column. Okay. In this case here, there's bracing as well, so you can see that the studs are being fitted around the bracing because the structure is being buried in those studs. And here's a picture of the column right here. So yeah, as you can see very clearly here, I didn't get on the inside of this building, but probably that's like a one, I don't know what it would be, maybe a 5x5 column, whatever that is, 5" by 5" and then a 6" stud going in around it, something like that. But the point is, it's someone's done their homework, and I can see there's a little bit of tolerance there that the sheathing is going to get installed right past that column. And if we went on the inside, hopefully it would be the same situation. Okay, so benefits of that, yeah, no columns, right? So retail tenants don't like columns. So burying the columns in there is a good idea. Something else to consider too. Again, I don't really want to get into the science behind this right now, but one thing you don't want to do with a infill stud situation is put your insulation in the stud space. That's terrible, right? That's terrible. Think about why. You would have hardly any insulation around the column, so a lot of heat loss there. And you're also going to have heat loss at every single steel stud going through your wall. And because everything's steel, it's got a high conductance, so there's a lot of heat loss. So it's almost pointless to be doing that. It's really terrible. So outside insulation is the best approach, and that's generally what we're seeing around town right now. Another approach that I think I forgot to mention this, that when we had a 6" column with a 6" stud, we started changing the stud size to a 203. And then you could get up to your 178 by 178 column, and it would still be buried in the wall. So going to a 203 stud or 8" stud, that just created really nice construction tolerance, basically. So that's an option, but the 203 stud isn't nearly as common as the 152 stud. And of course, you're losing, I guess, floor space as well. Couple or 50 mils of extra floor space. Okay, so now let's look at the other situation that's quite common. So I've drawn our little infill wall system there just for reference as we look at this one. So another approach is to do this. So here's the sheathing on the outside of the building. Here's the gypsum board on the inside. And this is in plan view again. And our insulation's out here like this. And of course we have our air vapor moisture barrier on there as well. And studs are in the wall, something like this. Okay, and then what you'll find is that the column is sitting here inside the building. So the wall has been pushed outside, outside of the structure, basically, of the I guess the vertical structure, anyways. This is called a bypass system. So it's very common as well. You don't see it used very often, I'd say, in retail at all. Although I do have a picture of one I could show, which surprised me with that. But you see it a lot in offices. And so, I forgot to draw the grids on our previous one. So the grids in this case would be centered in the wall stud, something like that. And then the grids would be, that'd be your grids basically. So in this case, your grids are here and here. And, now the discussion becomes, okay, well, what should that dimension be right there? And really what you're after is just enough tolerance in this area to get some work done, basically. So it could be you just leave the column exposed, but what if it needs to be fire rated and you want to fire rate that with gypsum board, or what if you just want to finish it with gypsum board? What if you want to put in a interior partition maybe between offices and you're going to have to fur around that with gypsum board? You just want to be able to get work done there. So you just find a nice cozy dimension to get that done. I mean, I guess if it was too close, you would just basically bring your wall, partition wall up like this and just square it off that way. Would be the way to do it. So that's very common. You know, what are the benefits of this? You gain a little bit more floor space, right? And if you know you're going to be burying columns on grid lines, if you space them out properly with offices, if you're going to be burying that column in walls, but partitions between offices, then yeah, why not? And you get that extra floor space. The other benefit of this is, you know, if we go back to the infill situation, there was quite a bit of coordination there, dealing with the base plate, making sure the engineer buries that base plate or makes it rectangular so it fits in the stud wall, um, coordinating with the structural engineer, making sure that the column fits within that stud space, you know, and you know, when you're early on designing a floor plan and that kind of stuff too, you might not even have an engineer yet. So taking this bypass approach is a little bit safer basically, because this column right here can change size quite a bit and you won't have a problem, generally speaking, for the most part. And so again, that's your bypass system right there. So the studs are bypassing past the column and the beam that's above the column, right? So think overhead. There's a beam overhead um, that butts into this column on two sides, and the studs are spanning past that stuff. Whereas opposed on the infill system, the beam is in here. So there's another, actually, that's another good point. Another big coordination item. So you might have planned that the column fits in there, but what about the beam? And then you got to make sure the flange, you know, because usually your beams are the wide flange beams like that. And you got to make damn sure that the flange isn't sticking out of the wall, basically. So it's not just the column, it's also a three-dimensional thing where you got to look at the horizontal too. So the bypass, you know, when you don't have an engineer on your job early on, this makes it pretty safe to do the bypass system. And so just looking at a picture here of a bypass stud system, so you'll see the difference there. The stud's clearly placed outside the structure there. So the column's in behind there, and the stud's spanning past that. So one of the benefits of this, right off the bat, that I could talk about is this parapet height. So quite often you'll see in buildings like this that this column extends up right there, and this corner column would extend up right here. And there might even be other posts put in here as well, steel posts put off the top of the beam. So if it was an infill system, then the stud would be stopping at the underside of that beam, and you'd put in your studs, okay, in an infill system. And then to build that parapet, you'd build a stud wall above that beam, essentially. And so what ends up happening is you don't get as much lateral resistance on that parapet because, you know, really you're just fastening that short stud wall right here down. You're just fastening that to some plywood and at the bottom track of the stud. So you get less lateral resistance. So what ends up happening is those you need steel in there basically. So yeah, this is the easy thing to do is you extend the column up, okay, and then you just add other posts in there to, and then there's usually a rail that goes along the top too, a C-channel rail. Actually, I can find a picture of that. And then yeah, you infill the studs between the beam and the rail. So you're just infilling studs between the steel. So the beauty of the bypass system here is that you can get a higher parapet, okay, without adding the steel, basically, because there's more lateral resistance in that system. So this building here really surprised me when I saw it getting built. Like I did a lot of retail buildings, and um, when I saw it and I saw they were doing a bypass stud, I was actually quite shocked because retailers generally don't like these columns here in their space, and now they're going to be in the space. I mean, they might build a furring wall on the inside to hide them, but then you kind of have two walls. What the other part that's really interesting about this as well, so these steel frame buildings generally have bracings. I can see some bracing right there. There's some steel bracing in there. So you remember in the previous pictures I showed that bracing, the studs were framed around the bracing. There's another brace over there. Now the studs are on the outside of all that structure. So what that means is on the inside, you see the bracing. So you'd have to fur around it if you didn't want to see that bracing on the inside, which again, like, the bracing's taking up an entire grid bay basically there. So you'd have to fur out a fair bit of wall and you end up with two walls essentially. So anyways, I was shocked when I saw this. I didn't see that very often. I'll just show an infill similar type building, a commercial building. And so here's an example of a steel framed building where they've extended these columns up, okay, here and here, and they put in another post here, and they're going to do an infill stud on this building. So that's kind of what it looks like after the fact. So again, the studs are framed in around everything. So what you're seeing here, let me just zoom in here. So what's being seen here is the stud. There's a stud track. Top stud track is right there. So that's on the underside of the beam, and then they put a stud in here. And there's a bottom track of a stud wall on top of the beam. There's the top track of it. You can see the steel. So that top track is actually butting to the underside of a C-channel or something right there. And then they build a stud wall between the beam. That's right here. The beam's right in there. And that channel up there. So that's your infill wall. So, to get that height of parapet with an infill wall, they had to add the steel, basically. And all you're seeing right here is they've just turned the studs and framed out the flange of the beam. So if we were to do a section through that beam, it would be a wide flange beam. And all they've done here is they've just turned the studs front face so that they could frame inside the flange, and then you can put your sheathing on past there. So anyways, that's the big difference. Okay, so if it was an office building or whatever, then again you'd have the columns on the inside. Bracing's a problem, I guess, to deal with. In office buildings or multi-story buildings, I guess you tend to have stair cores and elevator cores that are made of concrete, so they can work as your shear walls as well. So the steel bracing is reduced in that case, but that's kind of the lowdown of a bypass stud system. Okay, so now let's look at these bypass and infill systems in section. Okay, so what we've got here is um, the foundation. Okay, so this is the foundation, this is the floor. So this one here obviously assumes there's a parkade or basement or something. So here's our infill situation. So the blue, that's the gypsum board, that's the sheathing, and this green right here would be the column in the background. Okay, so the column's buried in the wall. So that would be our infill situation. Our bypass situation is, here's the sheathing, there's the gypsum board, there's the column on the inside. So there's our bypass situation. Now I have another one here called semi-bypass. Okay, and I'll get to that in a second when we move up to a second floor situation. But one thing that should become apparent here, looking at the infill and the bypass, is the location of obviously the foundation wall. So if the column needs to sit on a foundation, right? So, and as does the stud, ideally. I mean, it could be on a shelf angle or something, I suppose, but ideally it's sitting on a foundation. So, the relationship of the wall to the grid relates to where the column is basically. Whereas if you look at the bypass system, now the column's on the inside, but you're still going to want something below the wall, right? And don't forget, like we don't have it drawn in here, but there would be insulation put on the outside of this wall, and you're probably going to want some insulation on the outside of your foundation, and so on and so forth. So you still, the loads coming down this column are now not sitting on the foundation, right? They're missing it. So what ends up happening there is you have a pilaster in the parkade or in the basement below. So in plan view, if that's the foundation wall, you would see something like that, okay? And the column above would be sitting maybe like that or whatever. Okay, so you had to build out the concrete so that it's sitting, so that the column is sitting on the foundation. So that's one of the big differences in the foundation. So again, semi-bypass, there's no difference between these two options at the foundation level. So now let's move up to the second floor and see what happens here. Okay, so here's our infill system on the left. Okay, so again, we've checked that the flange isn't going to stick out past my sheathing, um, and everything's pulled back, so the sheathing could go nice and flush down the face of the building. Okay, and so what's not drawn here is the column. So the column would be buried in the stud space, like so. Okay, and the column's usually continuous, and the beam attaches to the sides of the column. Typically, it's not always like that, but generally that's how it is. Okay, so that's your infill and section at the second floor. Um, then we'll move along here to the bypass system. So with the bypass system, again, the stud is here, and now it relates to the plan view that we did, and it's placed outside the structure. Okay, and so one of the obvious weaknesses to this one is fire. There could be a fire running through the floor. Now it's not continuous through there, so you'd have to look at fire stops in there, for example. And again, the structure is visible. Whereas in this case, you could work out a system where you hide all that stuff. So you could frame out in the flanges of the beam and put some gypsum board in here like so, and overlap the one below, because there's a deflection happening here, so you'd have to deal with that in both the sheathing and the gypsum board. But nonetheless, as far as the relationship goes, that's what it looks like. And so the bypass is pretty straightforward, going past the floor structure essentially. Now the last thing I got here is what I'm calling a semi-bypass. So it may have a different name by some people, but I kind of coined that term, I think. So again, it's a bypass system where the stud is placed outside the structure. Okay, but what's happened here is we've extended the floor structure out so that the stud can stop at the underside of the floor, and then you can start a new stud at the top side of the floor structure. So I'm finding that this one's quite common for office buildings around town. I've seen it used quite a bit. I like it because you get the benefits of a bypass system. So if this was the roof structure up here, then I would still keep the roof structure cut off right there, right? And then you can extend that stud up and get the benefits of doing the bypass stud for the taller parapet without adding steel. But at the floor level, I guess the benefit of doing this is you don't mess up sequence of trades coming to site, I suppose. They typically work floor by floor, so it's still the traditional approach, I guess, of framing, and they can go floor to floor. You don't have to worry about that fire stop issue, and you still get the other benefits of the bypass system by getting more floor space and not having to worry too much about that coordination of fitting the beam in the stud space. And the column and the stud space and all those benefits basically of the bypass system, but you just got rid of maybe, I mean, I'm not a contractor, but maybe some trade sequencing, and then of course the fire stop situation. So yeah, the semi bypass is kind of my favorite. If I were to detail an office building right now, I would probably certainly take that approach. And so now that leaves the technologist to figure out, if it's not already obvious, I guess, in the design plans handed forward, now it's up to the technologist to look at the situation and figure out what makes sense.